starting off, we're looking at setting up our plumber block on our faceplate. So first things first, we grab our faceplate. I need to make sure I've got one of the faceplates that have an 840 RPM on them, because the jigs we're using, that's this part here, have been machined to actually fit these faceplates. So I take my block that I'm going to use to support my jig, my cast iron plumber block on. I put it on the faceplate, gently nip up those bolts. You've already marked out the casting. You machine the holes or drill and machine the spot face, and we use these little locating cones to actually position the casting on the center line of the holes. Do we have a 6mm Allen key? I'll just do them up finger tight. Okay, so I get a rough approximation of the location of that. So if you look down through there, you can see that I want to get this section of the casting, that hole that I've marked out, running approximately concentric to this part here. To double check that, I'm going to get my surface gauge. Now, the reason I'm using a surface gauge is I have these two pins that I can push out from the bottom of the surface gauge, and I can use them to run around the outside edge of my faceplate. The faceplate is machined concentric to the spindle of the lathe. So just like I'd set up a 4-jaw chuck, I'm going to put my scriber just sitting on the edge of that marked out line at some point to start with. Position the job by moving it on the surface of the faceplate, bring my scriber around, and I can see the difference I have. So I want to split the difference, so I need to bring it that way, just a tad. Alright, I'm going to go and reposition the scriber. So it's once again running over the top of the line, and I've always got to work straight up and down when I'm doing this. There's no point me looking at it side on. So I get a false reading if I look at it side on. Okay, coming back around again. So you can see as I go, I'm slowly splitting that difference between what's happening on this side of the casting and what's happening on this side of the casting. And up to the top. Okay, so that's pretty good. So then I go and I just snip up the bolts. I want to make sure that I don't go move the angle plate which is supporting the casting, because then I'm going to have to start all over again. Get a pressure on those bolts, come back and check again. And if need be, you can just grab a soft faced hammer and slightly tap it either way to get it right. Okay, so that's pretty good, as I said. We'll double check it again once we put it up in the machine, but it should be right if I make sure the spindle nose on my machine is clean, and in behind the back of my faceplate is cleaned out as well before I go stick it on the machine, which if you have a look at this one, it's not, so I don't know who used this last. I'm in all sorts of trouble. We have an out of balance load spinning around on the face of the machine. The last thing I want to do is introduce a vibration into the machine. So what I've got to do is I've got to put counterbalances onto the actual faceplate to counteract the out of balance forces. So to starting off with, we just make a rough estimation as to where I'm going to put these counterbalances. If I have a look at the angle plate I'm using, I have a large mass sitting here, so directly opposite that I need to put a bigger, or my counterbalance weight, further out from the center line of rotation. If I look across this plane, I don't have this big mass there, so I can have this one in a little bit closer. Just nip that up and nip that up. Can you hit the pause button? Okay, so we've put our faceplate up on the machine. First thing I'm going to do is I'm going to make sure the machine's in neutral. And I want to get a rough idea of how balanced this is. So to do that, I'm just going to roll the faceplate around. And what I'm looking to see is whether or not the thing will stop down in a certain position. So to show you what I mean, if I go and take these counterbalances off, I should be able to do it with just one. I go and rotate the job, and it always wants to fall to the bottom. Okay, so that indicates to me that I have a heavy mass sitting on this side of the faceplate. Tighten that up, tighten that up. Next thing I'm going to do is I'm going to bring my surface gauge up, and I'm just going to use it to double check and make sure I've got the thing running true to the center line of the machine. So once again, just like I'm setting up a 4-jaw chuck, I use the scriber, but this time I'm using the marking out lines on the surface of that casting. And I'm running around and I'm looking to see how well I've got that set up. So from the prick punch marks, we can actually get a clear representation of just how well I've got the thing set up. Good. Alright. If it was out a little bit, you just grab yourself a soft-faced hammer and just gently tap or move the job around to get it lined up 100%. But we did a pretty good job over on the table, so I'm just going to come back and lock that up. Make sure it doesn't move. Come back and check. That's pretty good. So now we've got the casting set up on our faceplate. Now, to do the actual turning operations, the first thing I'm going to do is I will bore this thing out. And the reason I'm setting it up on the faceplate is by having this sitting on the angle plate. If I bore the center of this casting, I'm guaranteeing that that bore is going to be square and true to the base. I go and face this surface of the casting. That means that face as well is square and true to the bore and to the base of the casting at the same time. You do the bore and the face, you take the casting off the faceplate, put your 4-jaw chuck back up, reposition the casting in the 4-jaw chuck on our machine surface, and then face it down to the 25mm. I don't need to worry about setting the thing running true to the center of the casting when I'm doing the facing, because I'm just doing a facing cut. Alright. Safety issues when we're looking at faceplate turning. If you look at the front of the lathe, I've got a lot of stuff spinning around out here that can grab me or drag me into the machine. So it is imperative, whenever you're using a faceplate, you make sure you keep your headstock clear of any loose items that could possibly fall in there and get flicked off out across the workshop. And always stand in this position. Never ever reaching across like this. Doesn't take much, a little slip and then you go. Okay? Keep yourself away from the job, protect yourself using the tool post. Now we're going to come back and look at our speeds. So I'm going to run the thing at about 470 RPM because I'm using carbide tooling. Switch her on. Start it up. Before I go do any machining, I just want to feel the head of the machine. The reason I'm doing that is I'm looking for any sort of vibrations. At the moment, nothing. It's pretty sweet. If you get a little bit of vibration and you're a little concerned, switch it off and readjust your counterbalances. Okay, but given that we're using pretty much the same setup on all machines, if you put your counterbalances in the same places as it's been shown, then this setup will be pretty close to right. Okay, and then we're ready to go. Remember, stand in this position when you're actually doing your work. Bore your hole out first, face it off to size, and then take her off the faceplate. We're all done. Any questions?